Hello, everyone. My name is Federico Andrade Rivas. I'm a PhD candidate at the University of British Columbia, the School of Population and Public Health. I'm going to be talking today about our project, mapping potential level pesticide exposures using a modular and scalable geospatial strategy. So we know now that planetary health is chemical contamination is one of the major planetary health challenges. It kills about 9 million people a year, most of them in low and middle income countries. And chemical contamination from agricultural drift is one of the major sources of contamination. However, most countries lack the capacity to assess, monitor, and control pesticides chemical contamination. And most of this is due to a lack of continuous national level data. Building on recently developed global data sets, we put together a strategy so we can merge all this data and create maps of potential exposure at the national level. So with this study, we aim to develop a modular and scalable strategy that could be applied to any country of the world using open source data and using publicly available global data sets. We use as a case study here Ecuador, which is a country that has one of the highest pesticides application rates per cropland area in the world. Their economy relies on in export-bound agricultural industry. Ecuador also has a large population at risk, relatively large rural population, remarkable biodiversity and ecosystems, but they also have very limited information at the national level of pesticides use. So beyond developing this approach, our objectives were also to identify areas where high human population densities and high levels of pesticides use overlap. And in addition, we also aim to identify areas where there is a concern both for human populations, biodiversity, and vulnerable ecosystems. How did we do this? We use a data-driven approach for geospatial analysis to identify a geographic grid. So we built a grid of more than 6,000 cells of 8 by 8 kilometers, where we brought together all these different databases. We look at different types of pesticides and also different ages of population that are concerned in terms of chemical contamination. But in addition, we decided to look also at places where there is an overlap of contamination to fragile ecosystems and large populations. Our results for Ecuador were alarming. We found that about 30% of the Ecuadorian population live in areas where there is high pesticides application rates. So there is potential for exposure. We know about only one other study that did a similar analysis at the national level, and it was conducted in Canada. However, they use detailed surveys available in North America as an exposure variable. And what they found in Canada is that about 6% of Canadians are exposed to high levels of pesticides or live in areas where there is a lot of high levels of pesticides. In our case, in Ecuador, it's 30%, so it's very concerning. We found like an area of a lot of concern, that is the region in the coast, where there is also high potential of harmful exposures to large populations. And the distribution of pesticides was different depending on the pesticides that we look at. And this is important in terms of like different levels of toxicity of these pesticides. In addition, we found an area where there is an overlap between biodiversity, high levels of biodiversity, and also large populations. And this is located in the Amazon. And finally, we also find places where there is high pesticides use, large human populations within a national park. And one of those is a park that is a UNESCO National Heritage Place. So we believe Ecuador is not an isolated case, and this type of analysis should be conducted in other countries. These methods allow us to prioritize areas where further exposure assessments should be conducted at a more detailed scale. Contamination by global food systems must be included when we are thinking and considering new development projects associated with intensive agriculture. The effects of contamination should be put in the equation when we're looking at the benefits and the drawbacks of these production systems. And geospatial data sciences provide valuable evidence to prioritize regions in a country with lack of local information where more controls and assessments should be conducted. There is a big challenge in environmental pesticides exposure research regarding identifying areas of concerns because of this lack of information of pesticides use. And here we're providing a tool that is readily available using open source data that is scalable, flexible, and modular. So please don't hesitate to contact me or anyone in the team if you need any further information. Thank you so much.